this is the last bit of learning we're going to do all school year. I just put it someplace. Here it is. Okay. So the first bit that I have to teach you is pitifully easy. But if you're going to be in my class next year for AP Chem, or if you're going to take any other chemistry after this class, you need to be paying attention to this because it's really important. Okay, so what I'm going to teach you today is about this symbol. I will explain this, what it means. Do you remember what this is called? It's delta, and it means changement. When you see the delta, it means that you've had some process that happens over time, because there has to be a final and an initial set of circumstances. Yes, sir?
What is this called?
That's a good question. It doesn't really have a name. I guess I would just talk, I would just put this under, maybe today's title can be enthalpy. So then, remember what H stands for? It is, but its proper word, or like its term in chemistry land, is called enthalpy. And what does that mean? That is the heat of a chemical reaction. The degree symbol, do you see that? Does not mean degrees. That degree symbol, when you see that next to any kind of a variable in science, it means that you are operating at what we call standard conditions. When we talked about the gas laws, we talked about something called STP. Do you remember what that was? Standard temperature and pressure. Do you remember those values for those? Temperature was, Demetrius, do you remember?
The temperature was 0 degrees Celsius.
Yep.
1 atmosphere.
Yes, so at 273 kelvins and at 1 atmosphere pressure. These kind of standard conditions are not the same as STP. The standard temperature is 298. What does that mean? What's the difference? It means that you're working at room temperature. Most of the time when you're dealing with standard conditions, you're talking about real chemical reactions that are taking place and not just the properties of gases. And real reactions need to be conducted by a real chemist, and a real chemist doesn't want to work in conditions that are 0 degrees Celsius. The pressure, though, is the same as it was. It's 1 atm. But now we also determine that there has to be a certain concentration of our aqueous substances. And that's so that we can compare apples to apples. If you use a more concentrated reactant, it means that you're going to make more products. And so if you want to compare your data to other scientists' data, you have to use 1 molar solutions. Obviously, this only affects aqueous solutions because liquids and solids do not have concentrations. They are infinitely concentrated. This could also this could also be gaseous substances as well. You don't need to have any of this memorized. If I asked you for it, I would give you that information in this class, but if you go on to any other further chemistries, you will need to have these things memorized. At some point, you're going to have to memorize a whole lot of things. It's just not right now. And then the last thing in this whole nonsense that I wrote down initially is the little letter F, and that stands for formation. And so what we're going to first learn about are the changes in the heat of a chemical reaction for the formation of compounds. And so all of those words are represented in this symbol. We just don't have to write them or say them every time. Okay, so I think that the best way to teach you how to use these things, well, I'm going to first write the equation on the board, and then I will give you your homework. We'll do some examples. The change in enthalpy of a reaction, RxN abbreviates the word reaction, is found by taking the sum. You guys familiar with this symbol from Mathland? It is the Greek letter sigma.
Sigma.
Yes, yes. Oops, I forgot my delta. So what does sigma mean? It is the sum of. So how do you calculate a sum?
Multiplication.
That's a product.
Add.
Adding is a sum. He decided the hot seat was too hot for him. I think it was Hunter's farts that threw him off. Minus the sum of that delta H's for the reactants. Okay, so write this down. Maybe this is something that you want to put in this little space here on the back of your gray sheet, maybe. I'm going to give you your homework so that we have some examples of how to do this.
Sigma, what is sigma?
Sum.
Sum of.
Sum of
The products.
It means adding up the things.
Some of the products change it.
Don't worry, I will show you how to do it. I think the showing you how to do it is probably easier than the saying how to do it.
Bacon live,
Come on.
Yeah. Red lobster.
But I think I get out of collaboration because my group collaborates on Tuesdays and we're going to be on tomorrow. So I think I'm off the hook. Tomorrow is a Tuesday and it's mission day. That you have, I don't know about that. Definitely not. All right, my friends, I want you to look at your gray sheet. In fact, I'm going to turn some of the lights on. Oh, sure. I'm sorry. I hate the lights more than you do. But there are some really little letters and numbers on the gray sheet. Okay, so let's just take a look at the back side. Has all of the enthalpies of formation on the back. Notice how the first line for every new element has the same enthalpy of formation. Its number is 0. And that's because it doesn't require or produce any energy when forming an element because the element exists that way in nature. And so it automatically already is. Therefore, it doesn't need any energy to create it, and it doesn't produce any energy by forming. It just is that way. Now, also notice a couple of things, like if you go down to the hydrogen section, God bless you, there are 2 line items for water. There's H2O liquid and H2O gas. You have to really be paying attention to which state of matter I give you in your homework problem or on the test. And then there's one I saw the other day. There's one that has 3 different options. Under phosphorus, so in the 3rd column, like all the way at the bottom, phosphoric acid can exist as a solid, as a liquid, or as an aqueous solution. Yes, Carter?
You have an extra gray sheet?
I do. Okay, so let's solve one of these problems, and hopefully that will help this make sense in your mind. I'm going just to do the first one. I have to write all of this out, so just bear with me.
Yeah. Exactly.
Okay, so now what you're going to do is find, guys, you're going to find each of these items on your gray sheet. Don't let me forget to hand back some work today too, though.
So do we just write the numbers underneath
Okay, so this is how I do this. For calcium phosphate, we're going to find that in the first column, about 2/3 of the way down, its number is negative 4,126. What's the unit of this number? Kilojoules per mole. How do we know that? Look at the top of that column.
We have to convert anything?
What?
We have to do convert or anything?
No, the only thing that you have to do is look at this unit. Now, this is the last time I'm going to ask you to write this unit next to all of your work answers. So, what is this unit? The unit is kilojoules per mole, but we need delta H for the reaction to be in kilojoules. So how do we get rid of the mole? That's to remind you that you need to multiply every single one of these numbers by the stoichiometric coefficient. So in the first problem, or in the first reactant, we would multiply by the number 1 because that's its stoichiometric coefficient. Now, this is the only time also I'm going to ever write the number 1 on there. You should know that it's 1 and that 1 times the number is that number. Okay, for the second reactant, we have to find sulfuric acid in liquid form. I see negative 814 on my gray sheet. Nothing hard about that. But now what should we multiply it by? Where did I get the 3 from? The chemical reaction. All of these are balanced for you on your homework, so you don't need to worry about balancing. You're just going through the motions. Calcium sulfate then, guys, thank you. Calcium sulfate is, thank you. And then we'll multiply this one by
3.
Perfect. Oops. And then your phosphoric acid is in liquid form, so make sure you write down the proper one. Don't get confused by that.
Wait, how do you know if it's getting rid of the bottom?
It tells you. Your problem will always tell you.
Yeah,
Except on number 3. So if you're working ahead, watch out for number 3. I'll explain that. I made a mistake.
You have to put kilojoules per mole.
You don't have to. Only that first time am I going to make you do it.
And then
Now, when you write your answer has to be in kilojoules. So maybe writing that in this little space here also would be useful. All right, so now our equation, our mathematical equation says take the sum of the products. So let's do that first. So you're going to multiply and add. So 3 times negative, what?
is that all in one thing? Or
Well, so this is what I'm going to type in my calculator. I'm going to type in 3 times negative 1433 plus 2 times negative 1267, and I'm going to get this as an answer.
oh,
Okay, but now looking back at my mathematical equation, I took the sum of my products, that's this answer. And I need to subtract the sum of the reactants. So I'm going to do the same thing. Negative 4126 plus 3 times negative 814. And you should get negative 6568. Each of those numbers are the sums of the enthalpies for the products, sum of enthalpies for the reactants. All right, now what you need to do is actually do the math. So we got this number, and we got this number, Oops. And now do the math. So negative 1633 minus negative 6568. And you should get negative 265. Did you get that? Can anyone confirm that that's the right answer? It would not be positive. It would not be positive because so this is the important thing. It's always products minus reactants because final minus initial. The final is what you made. That's your products. Your initial, yes. Okay, so your unit is, and that's it.
That's it.
All right, so show me on your hands a scale of 1 to 5. 5, this is easy. How do you feel? Do you want me to do one more? Actually, I do have to do one more because I screwed up. Let's do number 3.
Shut up.
I made a mistake.
Why you back here?
Okay, so see what you can do on your own. The mistake that I made on this homework, and I didn't even notice it. I wrote down for HCl aqueous, but then I didn't give you a line item for aqueous hydrochloric acid. So you'll have to use the one for the gas. Sorry about that. So I got negative 687 for the first one. You have to be careful about the water. We're going to use the 286, not the 242. But that is multiplied by 2. SiO2 is negative 911. And then the HCl gas, which is not how it's written on your homework because I was being silly, is negative 92. Okay, so we can calculate the sum of the products. I got negative 1279. And the sum of the reactants is 1259. So then your delta H of reaction should be negative 20 kilojoules. What does this number mean? It means that when you broke the bonds of the reactants, disassembled them, and then reassembled them as products, that reaction gave off 20 kilojoules of heat. So you as the observer, you as the chemist would feel that that reaction was a little bit hot. Not as hot though as this reaction in number 1. This was 10 times more energy. Questions on, yes, Dominic?
Have to write the delta H like
You don't have to. I just have so many numbers here that if you don't circle your answer, I won't give you any credit.
what?
If you don't circle your answer, I won't give you any credit. All you have is numbers all over. How do I know
13?
which one is the answer? So, circle your answer. What do you need to do to show your work? This is sufficient. This is sufficient. Can you do any less than this? No. No, because I can't read your mind, and I don't want to have to. Any questions on page 1? Okay, that was the easy bit. The next bit's a little more complicated, so get locked in.
Let's go.
Let's go. All right, turn your page to the next page. There's no good way for me to teach you how to do this except by just doing it. This is called Hess's law of heat summation. And it is pretty much like it sounds. Heat summation. Summation means that you add stuff up. Okay, so in each of these problems on pages 2, 3, and 4, you are going to be asked to figure out a way to add up the earlier reactions to make the reaction that has the question mark next to it. So let's just start by doing this, and we'll see how we do. Okay, so I'm just going to copy the problem onto the board really quickly. Now, Hess's law tells us that if you add reactions together, you can add their enthalpies or their whatevers, and that's fine. That gives you enough data. It will never be, however, never will it be that I give you a problem where you can just add this plus this and that's answer. Never. I will never give you this plus this equals this. So if that's what you're tempted to do, that's nice, you won't get any points. So we have to learn how to do this the right way. Okay, so this is the information we're given, and then we're asked to get those two reactions to add up to this thing. If you can do that, you'll be able to figure out what that delta H is. Okay, so this is like a 3-step process. If you do this, every time you will get the right answer. The first thing that you have to do is find where you have something in your mystery chemical equation in only one other place in the known equation. So I'm going to start by looking for sulfur. Sulfur occurs here and nowhere else. So then you can keep going. That's a thumbs up. Once you've found that, you have to ask yourself 2 questions. The first question is this substance in the same place of the reaction in the above reaction? So in other words, are they both reactants? Are they both products? Are they on the same side of the reaction? They are. Okay, so we do nothing. The second question to ask yourself is, are the stoichiometric coefficients the same? Are they? So we do nothing. If that's the case, what we're going to do is just recopy that equation down and thank God that it was an easy one. Oh boy. Okay, so you've not done any work until now. You need to write exactly what I wrote on this line. Give yourself a little bit of space though. Don't write super huge. No Michael Kuba penmanship.
Is that 0.2?
It is 0.2. Okay, so that takes care of the sulfur. Now the next thing that we're going to see in our mystery equation is O2. But look where O2 appears. It's got 2 places, and one of them is a fraction. That's a lot. And so if your substance in the mystery equation occurs multiple places, skip it. It doesn't pay. It does not pay to try to figure it out. Some people like to, but I don't recommend. So I'm just going to move on to the next thing, which is SO2. I see SO2, and it's in this second equation of my known information. So now I'm going to ask myself the 2 questions. Is it on the same side of the reaction arrow? No. So I'm going to have to flip my reaction around. Does it have the same stoichiometric coefficient? No. So I'm going to also have to manipulate that. How do you go from, by what number do you need to multiply this to get that? 1/2. So I'm just going to write it on here like this. I'm going to write -1/2 over here. That'll remind me of what I need to do. Okay, so I am going to recopy this equation with it being flipped and with all of the stoichiometric coefficients being multiplied by 1/2. So 2 times 1/2 is?
1.
And And then my reactants, 2 times 1/2 is still 1. What's 1 times 1/2? Good. So I successfully completed recopying that second equation. But now whatever you do to that chemical equation, you must also do to its enthalpy as well. So we flipped the reaction, which means that we have to flip the sign. So it shouldn't be negative anymore, it should be positive. And then we need to multiply by 1/2. That number is 91, positive, 99.1 kilojoules. Demetrius.
Why do we use negative?
Good question. When the reaction proceeds in this direction, the enthalpy tells me that it will produce almost 200 kilojoules of heat. If we're reversing it, so in other words, this would be like your phone's battery would be going in this direction. It would be using up, and you would be able to like do stuff on your phone. The reverse of that, though, is your phone needs to be charged. You need to plug it into the wall. That is adding energy from the surroundings to your system. That's a positive sign. And so when you flip the reaction, it means that you flip how the energy works. And so the sign of your new enthalpy needs to reflect that. So this would be like plugging your phone in because energy has to be added from the surroundings. All right, we're almost to the end. The next step is where we have to prove that what we did is going to add up to mystery equation. So if something occurs on both sides of the reaction arrow, you can cancel it. So the SO3s cancel right away because their stoichiometric coefficients are the same. It'd be like having 2 5s, one on one side of an equal sign and one on the other. If they're the same, you can cancel them. The oxygens are a little bit goofy. So when you see, I'm going to do this. How would you solve this for X? Would
Is that multiple?
Well, cross multiply, that's really interesting. I'm surprised that cross multiplying divide doesn't always work. It's not always a thing. Why are you laughing?
I'm joking.
Okay.
Just because I'm trying to see.
All right, gentlemen. All right, so we would have to combine these terms, right? How would you combine them? Do you guys not know how to do algebra, or are you just not talking?
What's 4 over 2?
Divided by 2.
Oh, shoot. Okay, all right, I guess that's true. What if we just want to combine the x's? We just as they are, we're not going to move the fractions around.
2x.
You just plus the top.
Minus 1/2 x over 2.
You would subtract them. You would move this one to the other side. So what do you get when you do this math? You get 1x. So that's what you'll have here. This will be a 1 and this will go away completely. Is that the reaction you were supposed to make?
Yes.
If that's mystery equation, you can add these two numbers together. If it's not mystery reaction, you have to go back and fix something. You cannot solve these problems unless you do this. If you just add some shit together, you might get lucky and that might be a thumbs up for you. There is no other way to do this than this process. Can somebody give me an answer for this? Is it negative 296.1?
Negative 296.1.
Thank you. That's your answer. How many significant figures should you have? Well, you're subtracting and adding in these problems, and so it's by the smallest number of decimal places. Smallest number of decimal places. All right, show me on your hands how confident you feel. 5 being very confident.
This?
Yeah, that's pretty legitimate.
Oh, why are you flipping it off?
Hey,
Oh.
Cole, you gotta behave yourself, buddy.
Sawyer.
Let's do number 10. 10 looks pretty hairy. All right, so I'm not going to copy everything down this time. Let's just try to talk through this. The first thing that we want to do is find carbon and see if it only appears one time in the known equations. Does it? Does carbon occur more than once?
By itself?
Yes, just by itself. Only one carbon. There's only one of it, and it's in the second reaction. Okay, so ask yourself the two questions. Is it on the same side?
Yes.
Good. So no change. Does it have the same stoichiometric coefficient?
No.
So what are we going to have to do to that reaction? Times everything by 2.
Can we run back what just happened?
Yes. Okay, so we want to find that carbon, Dominic, in any
On
of
the way bottom.
the one down here in mystery equation. We want to find this carbon someplace else in known equations where it only appears, like we're hoping that it appears only once. And it does only in the second equation. So then we're going to ask ourselves the two questions. Is it on the same side of the reaction arrow as in mystery equation? The answer is yes, because they're both reactants. But then the second question is, do they have the same stoichiometric coefficients? The answer is no, because mystery equation needs 2 of them, but known equation has only 1. So we multiply the entire second equation by 2. So now you have 2 carbon, 2 oxygen, 2 carbon dioxide. What do you have to do to delta H then?
That's times it by 2.
Times it by 2. So then that's 7 to 88?
Sure.
And it should be negative, right? Whew, I got pretty confused there. I didn't know which problem I was doing. Okay, so now the next substance in mystery equation is H2. Does that only appear once?
Yes.
In equation 3. Okay, so then ask yourself the two questions. Is it on the same side?
Yeah.
Does it have the same stoichiometric coefficient?
Yeah.
So don't do anything, just recopy it. And then we thank God for giving us an easy one. Okay, then the last substance in mystery equation, is C2H2. Does that only appear once? In equation number 1. Okay, so then ask yourself the two questions. Is it on the same side?
No.
No, so we're going to have to flip it. Does it have the same coefficient?
Yes.
So nothing but flipping it. Oops. What will you do to delta H for that last equation?
Negative?
Yes, well, it started as negative, so now it'll be positive. But you're right. Okay, now we have to prove that our puzzle solving is going to add up to mystery equation. So let's cancel the things that occur the same on either side of the reaction arrow. I see 2 CO2 and 2 CO2, those are gone, those are good. There's 2 water as well. I'm sorry, 1 water, but on either side, so that's good. And then there's all of this nonsense with the oxygen. Here you have an improper fraction. What is this number really?
2.5.
That's 2.5. What do you have here?
2.5.
So everything cancels out. So then add up what you have left and say a little prayer that that's what mystery equation is. Is this mystery equation? It is. So then just add up this. I don't remember the answer, so I have to do the math as well. I got 226. Can anyone confirm? Okay, good. Now, how do you feel?
I don't think that's off.
Number? Show me a number. Did anybody get a worse number than they had before? Okay. Okay. I feel like that's very valid. I had like in my college career, I had one chemistry professor who was like actually a really nice guy, and I felt so bad because every time I like walked out of his classroom, I felt like I knew less than when I walked in. But he was just the nicest guy. Yes, Ian.
I know the bathroom, we're gonna do some more stuff.
We're gonna do one more problem. So can you wait 5 minutes?
Yeah.
Okay, then you may go. Let's do number 11. 11 has a trick, like a tricky bit in it. So I feel like if you can manage 11, you can manage them all.
66% of those parts. This is why you have those kind of negative.
All right, so my friends, there's one other rule. There's one other rule about Hess's law that you have to know, and that's you may not use the same no-one equation twice. So if you already use like reaction 1, you can't use it again. You can only use each reaction once per problem. Okay, so let's look for the first thing. In number 11, our first substance is NO. Does NO appear only one time? Last equation. Is it on the right side of the equation? Or sorry, is it on the same side of the equation?
Yeah.
Does it have the same coefficient? Okay, so copy.
NO2's on there.
NO2, but we're looking at NO right now. No, NO2 is not. It only is once.
I was looking at NO and NO2.
Ah, idiot. Okay, so then don't forget to write your delta H down. It'll save you a lot of hassle if you do that straight away. Okay, so now we're looking for just O. Does just O appear only once?
No.
It does.
Yeah, it does.
Second equation.
In the second equation, it only appears once. You're just looking for oxygen in its monatomic state. There's a 2 in front of it, yes, that's true. That's true. Okay, so is the O on the right side, or sorry, is the O on the correct side in reaction number 2? Does it have the right coefficient?
No.
No. Okay, so what are we going to have to multiply that reaction by? Negative 1/2. So we're going to get a 2 and a 1/2 O2. And so then this is going to be, what do you mean what?
Isn't it if 1/2 O2?
What?
Negative 1/2 O2.
No, the negative number only goes here. Because it's not like, it would only be negative if we were like losing it and we're not. I took the value from here and multiplied it by negative 1/2. I took positive 495 and I multiplied it by negative 1/2, and that's how I got this number. Do you see why I did that?
Yeah.
I flipped the equation, so it's got to be negative, and then we multiplied everything by 1/2, so that's also the half. All right, now what?
NO2.
Find NO2. NO2 only appears one time, but look, you've already used that equation. You've already used that equation. You can't use it again. So, does that mean that you're done?
No.
Well, give it a check.
Yeah.
Does anything cancel out? Does anything cancel out? So then the equation that you're left with, oh, the O2 adds, they're on the same side now, so you would add them together. Is this mystery equation? No, so you gotta start over. Or, I mean, not over, but you gotta do something else. So what does this equation have that it shouldn't? The O3? Let's look at that firstly. There's another equation that we've not yet used that has O3 in it. So, I'm going to have to erase all of this now. Oh, hang on a sec. Give me a second. There we go. Okay, so we want to get rid of this substance here. Which side of the reaction arrow does it need to be on if I want to cancel it out? It needs to be on the right side. So how can I manipulate this top equation to make it that at least that product look like this? Flip it and change it to negative, but you also, the coefficient isn't the same. So you're going to have to multiply the whole thing by a half as well. No farting. Did you just say something about farting?
No, I said this one's hard.
Oh, I thought you said don't fart.
Oh, I guess that's it.
I mean, okay, so now, oh, don't forget this. Multiplying that top reaction by negative 1/2 would give you,
2/5.
thank you. Okay, let's see if we can add them up now. The O3s cancel out, praise God. What else? The oxygens, do you have 3.5 oxygens on this side? Or sorry, 3.5, not 3.5. And so your final equation now is this mystery equation?
Yes.
Now you can add them together.
Negative 223.
Negative 223, Cole?
Oh,
Thank you.
230.
Oh, my bad. There you have it. These questions are not hard. They're a little bit like solving a puzzle. It's going to take you a minute to get it figured out. I really recommend that you spend the next 25 minutes working on this and getting your questions asked. Excuse me, it'll be a lot easier if you do that now than if you wait.
What are we going to do?